So yeah, hi guys. I hope you are all well because today we are going to start with a session 2. This is a session 2 that will be based on your previous session. We will be taking some notes from that and we will be continuing with the chapter triangles and its properties today. Remember, this will be the session 2. We have just covered up our basic things related to a triangle and the basic congruency criteria and what actually is congruency. So we have just covered up our basic things related to triangles and some of its congruency criterions. Now the remaining questions that were left from our previous exercise, then we are going to move forward towards our exercise, which should be exercise 7.2. Then we will be focusing on the remaining portion, isosceles triangle and its properties. Then we'll focus on whatever left. So with that being said, let us start with the video and let's revise whatever we have learned up till now. So let's start with this. So revision. First of all, you guys remember what a triangle is. We have already covered this up. So triangle is any three-sided figure such that its three vertices are not lying on the straight line. Like ABC is a triangle in which none of the 3 points are lying on the straight line. So that means this will be a triangle. It has three vertices, three sides, three angles, right? That was the basic thing regarding a triangle. Then we had the congruency criteria, right? We were talking about the congruency criteria. So what were the congruency criteria? They were your side congruency criteria. Actually, before that, let's get to the point of congruency. So what was congruency? You guys remember congruency was what? It was that property of two figures such that if you place any two figures on one another, you end up getting just the same thing. That means when you have been given two figures, let's say these are the two rectangles, so let's call them, they are two squares. Let's say this is square 1 and this is square 2, such that each of these squares has the same dimension. Let's say this is 4 centimeter and that is 4 centimeter too. Congruency states that if you put one figure and place it on the other, and after placing it on the other one, if you look at from the top or the bottom and you can only see just one figure, you cannot see the bottom one or the top one. If you are looking from the top, you cannot see the bottom one. If you are looking from the bottom and you cannot see the top one, then you guys will be saying that the figure is what? That the figure is congruent. That means both figures are congruent. Now in this case, we had certain criteria for congruencies. So first one was your side congruency criterion, in which we had a pair of triangles. Let's say these were the two triangles ABC and let's say DEF. This congruency criterion stated that if you had all the three sides of one triangle congruent to the three sides of another triangle, then you would be having this side congruency criterion. But in this case, while you're talking about congruency, you just have to bear in mind, you just have to keep in mind that you have to place the the equivalent vertices over equivalent vertices. That means if side AB is equal to DE, that means if you are putting this triangle ABC on DEF, then you have to place it exactly like this, such that vertex A should lie on D, vertex B should lie on E. Similarly, if you have been given like this, AC is equal to DF, then you guys get the idea. Vertex A will be lying opposite to D, or you can say exactly on D. Vertex C will be on F, and finally if BC is equal to EF, then you get the idea that triangle ABC, this triangle will be congruent to triangle. The vertex opposite to A is D, vertex opposite to B is E, and vertex opposite to C is F. So using side congruency criterion, you will be saying that the figure which is given to you, these both figures will be congruent. And once you have proven the two figures congruent, then you can prove the remaining parts congruent too. Remember, in the congruent figures, in a pair of congruent figures, all the 6 parts are congruent. That means if these 3 sides are congruent to these 3 sides, then remaining these 3 angles will also be congruent to these 3 angles. So in congruent figures, you guys must remember this, all 6 parts of triangles will be congruent to one another. So that will be the main thing. That was the case of your side congruency criterion. Now we were talking about side angle side congruency criterion. It was quite easy. If you had been given a pair of triangles, let's say ABC was one triangle and there was another triangle DEF. If you had been given these two triangles, you guys must know this. This criteria states that there will be a side there will be another side, and there will be angle between those two sides. So if you have been given that AB is equal to DE, you have been given that angle BAC is equal to angle EDF, and you have been given that AC is equal to DF. Now you guys can clearly look here, AB is equal to DE, this angle A is equal to angle D, and ultimately this side is equal to that DF. That means AC is equal to DF. Then you will be having this congruency criterion, side angle side congruency criterion. Don't get confused here, there is no such thing as side angle criterion. That has already been discussed in a previous session. If you want a little bit more clarification on this, or you are having any doubt, I will be recommending you guys to just download our application, get yourself registered. We have recorded sessions there. I have just put an around 30 minutes especially on explaining this concept. In a previous session, I've also explained this concept in detail. There I had taken around 15 to 20 minutes to just explain this one. If you are unable to find that video, don't worry, we have structured content available on our application and on our website. So you can just have to get yourself registered. You will be getting various recorded sessions, a lot of practice questions. You will be having variety of things available there, all in a proper format. So just get yourself registered. So if you are having any doubt, that will be the recommendation here, or you can just go back to the video, the previous session. You can find that on our YouTube channel also. So you can just have there. So remember, there is a criteria which is side angle side criteria, but there is no congruency criteria which is side angle criteria. That has already been discussed, so I'm not going to jump into it because I have more things to cover up. Now let's go towards our next congruency criterion, which was angle side angle criteria. Now this was opposite to your side angle side, in which you had what? A pair of sides and angle between them. In this case, you will be having a pair of angles and the side which is sharing both of the angles. So if you have a pair of triangles, let's say ABC is a triangle and DEF is a triangle, you had what? You had this. If angle B was equal to angle E, angle C was equal to angle F, and BC was equal to EF, then you will be having this congruency criterion, which is angle side angle. So you can use angle side angle criterion to prove these two triangles congruent, and there can be this, remember, there can be angle side congruency criterion, because that is possible, because with the help of these two you can calculate the third angle and you can easily find out whatever you have to do. So this congruency criterion does exist. I have already explained this, why this exists, but not side angle. So again, if you are having any doubt, you can just revert back to the video of our earlier session, or you can just go to our website or download our application, get yourself registered. So this is the main thing. These are the 4 congruency criterions, along with one more congruency criterion, which is right angle hypotenuse side. We will be explaining this today, most probably today, or in our next session, which will be going to be held on tomorrow. That means it will be tomorrow. So this congruency criterion states that this is specifically reserved for your right angle triangles, in which you have what? A right angle, a pair of sides, and a hypotenuse, right? So this congruency criterion will be stating that if you have a pair of right angle triangles such that the right angles are equal, one of its two sides is equal to the one of the two sides of the another part. That means if this side is equal to that one and the hypotenuse is also equal, then you guys will be using this RHS property, congruency criterion, which is right angle hypotenuse side criterion. I will be explaining this today, most probably. So with that being said, I hope you guys are able to recall each and everything. We just have consumed 10 minutes on this revision. I hope you guys are able to recall everything. Now let's move forward and start with the remaining questions that were left. So this was the question that I had given you for homework. I hope you guys were able to solve this. If you weren't, just look at this one. So we had what? We had this one, that line L is a bisector of angle A. This L was bisector of angle A. Then you had to do what? Angle A and B were what? Angle A and B at any point on C. It was this. We had to prove that APB and AQB were congruent. So in triangles AQB and triangle APB, I knew this angle was being bisected, right? L was the bisector of angle A, and I have been given that BP and BQ from C. It was this. These two were 90 and this side was common. So you guys see angle side. So in these two triangles, I could say angle QAB was equal to angle PAB. It was given because L was the bisector of angle A, and I knew AB was equal to AB was equal to AB, which was common. And I also knew angle AQB was equal to angle APB, which was 90 each. So you guys do remember that there is a congruency criterion, which is angle side, and that is what we are using here. See, angle, and this is a total different side. So this will be angle side congruency criterion. Don't get confused here. This is not angle side angle. This is angle side, because side is not the one which is sharing both of the angles. So using angle side, triangles AQB and APB are congruent, and you can simply say that BP is equal to BQ CT. You guys remember when you had proven the pair of triangles congruent, then you could easily prove the remaining portions congruent too, using your congruent part of congruent triangles property. So that will be the case here. So if you have proven a pair of triangles congruent, then ultimately you have the authority to just prove the remaining portions congruent too, because if they are able to cover both one another completely, then that means that all parts are congruent to one another. So that will be the main case. Now let's see what do we have in the sixth question. Now remember, this is very important question. In this we have what? Let's see. In figure 7.21, this is the figure right here. AC is equal to AE. You have been given that AC, which is this side, is equal to AE. That means the double dashed one. And AB is equal to AD, the single dashed one. And angle BAD, which is this one, is equal to angle EAC, which is this one. These two angles are also equal. I have to show that BC is equal to DE. I have to show that this BC, this complete BC, is equal to this complete DE. Now for this, if you just focus on these two triangles, in order to have my BC, I need to have which triangle? I need to have this entire triangle ABC, right? We need to have this entire triangle ABC, only then I can have BC. And in order to have DE, I need to have this triangle, which is like this, which is ADE, right? ADE. So we need to have these two triangles. Let me just highlight the triangles that I'm talking about. So firstly, we need to have this triangle in order to have BC. Then I need to have, let's use this one. We need to have this triangle. I hope you guys are able to distinguish between two. So we need to have these two triangles. Now, in order to have these two triangles, do you see anything common between them? Although I can see this AB is equal to AD, I can see AC is equal to AE. Can you see anything else? Is there anything else? See, AB is equal to AD, that is clearly visible. AC is equal to DE, that is also visible. But one thing is which is not visible is, you guys see both of the angles, angle A are similar, right? Angle A is common to both, but just a difference is that there is angle BAC and there is angle DAE. Now you guys see, if you just distinguish between both of the angles, angle BAC will be this angle right here. This will be angle BAC. Okay, let me just choose the different angle. So in order to identify angle BAC, which should be this one, and in order to have angle DAE, that will be what? That will be this one. So you guys see, if I just tell you one thing, I know this portion and this portion, both of these portions are equal, and this portion right here is common. That means angle BAD has been given that it is equal to angle EAC, and I know angle DAC is common to both. Is common if I need angle BAC and angle DAE. In order to have angle BAC, I need to have what? You guys see, angle BAC is what? Angle BAC is angle BAD plus angle DAC, right? If I add angle BAD and angle DAC, I will be getting what? I will be getting BAC. See, angle BAD, which is this one, angle DAC, which is this one. So if I add these two, I will be getting what? I will be getting angle BAC. And in order to have angle DAE, I need to have what? I need to have this angle EAC, which is this, plus angle EAC, which is this. See, adding this angle, adding this, I will be getting this complete. So guys, see, I know these two angles, BAD and EAC, they are already equal. And we are adding equality to equality. So, will the answer be different? Or in short, if I just do what? If I just write it here, I know in place of BAD, I can write angle EAC. So, angle BAC will be same as angle EAC plus angle DAC. And I know angle EAC and DAC, both are what? Both are angle DAE. So, I can see angle BAC is equal to angle DAE. So, in short, we have just proven that in our both triangles ABC and DAE, AB is equal to AD, AC is equal to AE, and angle BAC, which is this one, equals to angle DAE, which is this one. And this is what we had to prove. I hope you guys are able to understand this, because this is very important. If you want me to repeat it again, then remember this. These two parts, these two angles are already equal, and we are adding equality to both sides, such that we will be able to get BAC that will be equal to angle DAE. Reason being, BAD and EAC both are equal, and we are adding equality to equality. So if we add equality to equality, our answer will still be the same, or we have just proven it. See, in place of BAD, I can easily write angle EAC. Angle EAC plus DAC will be giving me angle DAE. So this is very important. I hope you guys have understood this. Now we just have to prove it. So let's just come to the solution. So in triangle ABC and triangle ADE, remember the naming should be on spot. ABC is this, ADE is this. So on B will be lying D, on E will be lying C. So that will be the case, and A will be placed as it is. You can take the help from here. See, A same, C has E, and B has D. So that will be the case. So in triangle ABC and ADE, AB is equal to AD, AC is equal to AE, and angle BAC equals to angle DAE. You guys see, don't get confused. This is not side angle, this is side angle side. So using SAS, triangle ABC and triangle ADE are congruent, and you can easily say whatever you want to prove. BC is equal to DE, CPCT. I hope you guys were able to understand this. This was very important question. So again, if you are having any doubt, just pause the video right here and do it the sum on your own, then follow up with the video. So I hope you guys have understood the case and you don't have any doubt in this. Now let's move forward and see what do we have in the 7th one. So in this question, this is again very important question. We have what? We have this one. AB is a line segment. AB is a line segment. P is the midpoint of and P is its midpoint. AB is a line segment, P is the midpoint, such that this portion is equal to that one. D and E are the points on the same side of AB. D and E are on the same side of AB. That means upwards. D is here and E is here. Angle BAD, which is this one, is equal to angle ABE, which is this one. These two angles are equal. Similarly, EPA, which is this, is equal to angle DPB, which is this. We have to prove that angle DAP, that means this complete angle, will be congruent to EBP, this complete, and AD is equal to BE. We have to prove AD is equal to BE. Now this question is exactly similar to the one we have already done. We will be using the concepts here. So you guys see, in order to have the triangle DAP, if I just erase this for a moment, and if we just focus on the triangles DAP, so DAP is this one. Bear with me, this is DAP. And if we just focus on EPB, so EPB is this one. Right, these are the two triangles. And you guys see, in order to have this angle, in order to have angle APD, I need to have this APE plus EPD. If I add these two, I will be getting this complete angle. Similarly, in order to have this EPB, I need to have what? This EPD plus BPD. So if I add these two, I will be getting this complete angle, right? But you also know this, that these two angles, that means angle APE and angle BPD, both are equal, and you are adding equality to equality, so your answer will still be equal. And now we come to the solution. So you guys see, this angle is equal to that one, this complete is equal to that complete, this side is equal to that one. So angle, side, angle, triangles are congruent, and you can easily state that AD is equal to BE. So that will be the main thing. Now let's prove this. So in proof, I know angle APD. That will be what? That will be angle APE plus angle EPD, right? Similarly, angle BPE, that will be what? That will be angle BPD plus angle EPD. And I know APE, or you can say, yeah, this is the case, EPE or APE, meaning is same. BPD, or you can say DPB, both are same. These two are equal, so you can easily say angle APD is equal to angle BPD plus angle EPD. And you guys see BPD and EPD gives you BPE, so angle APD is equal to angle BPE, both are equal. Now you just come to the solution. So in triangle APD and triangle BPE, I know AP is equal to BP, I know angle DAP equals to angle EBP, and I also know this angle APD equals to angle BPE. Everything has been given to me. See, BAD is this angle and that angle, so everything is given to me. Angle, side, angle, triangles APD and BPD both are congruent. BPE both are congruent, and you can easily say AD is equal to BE. Or if you want to just take the same naming, so you can just say in place of APD you can say DAP, and in place of this you can say EPP. So you can take that name also, no worries. You just have to prove the same triangles congruent, and you just have to prove you just have proven the same triangles. So it does not matter which kind of name you are taking, provided your name is correct and your triangles are accurate too. So we have taken the same triangles, but we have named them differently, but the triangles are same, so that does not matter. You can say ADP, APD or DAP, that all three different names mean the same thing. So that will be the important thing to note here. You can name them accordingly, or you can name them like this, but your whole result will be same. AD is equal to BE, which is CPCT. I hope you guys have understood the case and you don't have any doubt in this. Now let's move forward and see what do we have. Now this is the final question from your exercise 7.1. This is very important. Remember, this is the most important question of this exercise. It states that in a right angle triangle ABC, keep in mind it is a right angle triangle ABC. So ABC is a right angle triangle, right angle at C. So that means this is 90. This has been given to me. It is 90. M is the midpoint of hypotenuse AB. M is the midpoint of AB. So that means BM is equal to AM. C is joined to M. C has been joined to M and produced to point D. See, this point has been produced to D, and you have this DC now, such that DM is equal to CM, and you have been given that DM is also equal to CM. Let's just mark this one differently so that you guys are able to distinguish the differences here. So DM is equal to CM. Now we have to prove what? We have to prove that triangle AMC, which is this one, is congruent to triangle BMD, which is this one. Remember, A is opposite to B. It has been stated here. A is opposite to B, M is same, and C is opposite to D. In this case, D is not directly opposite to A. Actually, we are just folding this figure invertly. This point will be going there. That will be the main thing to note here. Now for this, if I take these two triangles, we have to prove them congruent. Then we have to say DBC. That means this is 290. This has to be 90 again. Then we have to prove that triangle DBC, this complete triangle DBC, is congruent to triangle ACB. That means these two triangles are congruent, and CM is equal to half of AB. We have to prove that this CM is equal to half of AB. For this, we have to do what? Now, let's see what we can do in this. So firstly, if we take these two triangles, I know this side is equal to that one, this side is equal to that one, and these two angles are vertically opposite. So using side, angle, side, triangles are congruent. Now I can do what? In order to prove the second part, can I say once these two triangles are congruent, I can say angle A, this angle BAC is equal to angle ABD. That means this. Now you guys see, if I just look at these two triangles are actually what your alternate interiors to. See, if these two lines are the cases, we are talking about BD and AC, and AB is the transversal, I know pair of alternate interior angles are equal. That means these two lines have to be parallel, right? If a pair of alternate interior angles are equal, then the lines have to be parallel. So if the lines are parallel, can I say this? Sum of these two angles has to be 180, because in parallel lines, sum of co-inter angles is also 180. Out of that, I know this is 90, then remaining this will be what? This will be 92. So we have just proven these two parts. I know if I now, this is quite easy. If I take these two triangles, I know, and also I can say BD is equal to AC. We can also prove this one. Now this is quite easy. In these two triangles, DBC and BDC and ACB, this is quite easy. Now we can do what? BD is equal to AC, already proven. This we can say this side is common and this is 90. So side, angle, side, triangles are congruent. Using CPCT, we can say CD is equal to AB, and ultimately we can say CM is half of AB. So that will be the theoretical approach to this question. Don't worry if you are getting confused. I am going to do the entire solution for you. Don't have to worry. I will be doing it now. So let's just start with the solution and do it part by part. So for the very first part now, in triangle AMC and triangle BMD, in these two triangles, I know DM is equal to CM, I know BM is equal to AM, and I know angle DMB equals to angle CMA, right? This is already given, this is common. Now guys, see side, angle, side, triangle AMC is congruent to triangle BMD. Now we can say angle MAC, which is this one, equals to angle MBD, which is this one, CPCT, right? Now I know if that is the case, I know angle MAC and angle MBD are alternate interior too. If that is the case, so we have this AB is transversal. This implies BD is parallel to AC, right? Let's just do one more thing here and say BD is equal to AC2. This is also CPCT because that will be coming handy later on. So let's just prove it here. I know BD is parallel to AC, therefore can I say this? Angle DBC, if BD is parallel to AC, now I can simply state that angle DBC equals, you can say angle DBC plus angle ACB, actually CAB. Let's just write it like this. So equals to 180 degrees. Now this C is what? This is 90. So angle DBC will be what? It will be 180 minus 90. It will be what? It will be 90 degrees. So you guys see angle DBC is 90. So second part already proven. Now we have to solve the third and the fourth part. Now for that it is quite easy. We just have to take the remaining triangles. So in third part now, in triangle DBC and triangle ABC. So if we were talking about these two triangles, B was opposite to A, D was opposite to C. But if you are talking about these complete triangles, then D is opposite to A and B is opposite to C. That will be the thing to note here. So in triangles DBC and ACB, we have this. I know DB is equal to AC. I know angle DBC equals to angle ACB, and I know BC is equal to BC. This is common. This is 90 each, and that is what? That is proven. So you guys see side, angle, side, triangle DBC is congruent to triangle ACB. Now you can easily say that CD is equal to BA. You can easily state this, that CD is equal to BA. And you guys know M is the midpoint of AB, therefore BM is equal to half of AB. Also you have been given that DM is equal to MC, that means M is half of CD also. So you can say CM is equal to half of CD2. Let me just erase this. CM is equal to half of CD because M is the midpoint 2. and CD and AB are both equal, so you can easily say CM is equal to half of AB. So you have just proven your fourth part as well, and this will be the end of your exercise 7.1. I hope you guys have understood each and every sum in this. Remember the last three sums that we have done today, that means your 6, 7 and 8, these three sums are very important. Try to do them as many times as you have to, just in case you just have to know how you're going to solve them. So practice as many times as you can, but you have to do them on your own. So with that being said, let's move forward and start with the remaining portion of today's session. So now we are going to move forward and study the properties of triangles. We just have understood the congruency criterions. Now we are going to talk about some basic properties related to kinds of triangles. So in this case, we have the very first triangle right here. We have isosceles triangle with us. So what is an isosceles triangle? See, isosceles triangle is that triangle in which you have a pair of adjacent sides equal and the base two angles are also equal. So this property states that, this is the theorem, it states that angle opposite to equal sides of an isosceles triangles are equal. And you have the converse of this theorem, that sides opposite to equal angles are equal. We are going to prove this one in a bit. So this states that in a triangle ABC, if AB is equal to AC, then you can say angle ACB will be equal to angle ABC. Similarly, if angle ACB is equal to angle ABC, then you can say AB is equal to AC. So these are the two theorems that we are going to prove now. So for this, let's start with the proof. So theorem 7.2, like I've already written, I've already told you, angles opposite to equal sides of an isosceles triangles are equal. Now for this case, we have to do what? We have to start with this. So with this, let's see. Let's construct an equilateral triangle. Sorry, let's construct an isosceles triangle, pardon me. So this is an isosceles triangle ABC. Okay. Do what? Take an altitude AD. Now you guys know what an altitude is. That will be a perpendicular, right? This is your height. So we did what? We had a triangle ABC. Triangle ABC was an isosceles triangle. We did construction. We constructed AD, B and altitude. Okay. We constructed an altitude to side BC. We did this, right? Such that angle ADB equals to angle ADC equals to 90 degrees. That will be the main thing to note here. And you have to prove what? Required to prove is angle ABD equals to angle ACD. This is the main thing we have to prove, these two angles equal. Now for this case, remember the proof that we are going to be doing today, that will be same proof that we are going to use with our RHS, right angle hypotenuse side criteria. Now guys, see, we are dealing with two right angle triangles here. So in this case, I know I have been given what? Given is AB is equal to AC. That has been given to me, that the sides are equal. That side is equal to that one. So guys, see, side opposite to your right angle is always your hypotenuse. Now guys, know your hypotenuse are already equal. You guys see, this side will be common and these two angles are 90, so they will be equal to. So if I just come to the proof, I know in triangle ADB and triangle ADC, I know AB is equal to AC, I know angle ADB equals to angle ADC, and I also know this AD is equal to AD. Now guys, see, this is given, this is 90 each, and that is common. Now in this case, don't get confused here. There is no such thing as side angle, and you guys see, we have two different side and an angle which is on the third side. It is sharing it is not lying between these two sides. So you cannot say this is side angle side criteria. There is no such thing as side angle criteria because we don't have the angle between this. So there cannot be side angle side, and there is no such thing as side angle. So this has to be a right angle hypotenuse side. So you guys see, that will be the case here. This is right angle hypotenuse side. So using RHS, your triangles ADB and ADC both are congruent, and you can easily say angle ABD equals to angle ACD CPCT. So you can easily prove them. This was quite easy to understand. Now in its converse, you have to do what? You have to prove that the side opposite to equal angles of a triangle are equal. Now this is exactly the way we have done, but we have to have the bottom up approach. Now in this case, you will be having what? see, if I just move forward, we have one more time an isosceles triangle ABC. Let's say this is the case. This is an isosceles triangle ABC. We have taken an altitude AD such that this was 90 and this was also 90, and we had been given that the angles were equal, the base angles were equal. That means angle ABD, which was this one, was equal to angle ACD. These two angles were equal. These two angles were equal to, we had to prove that AB was equal to AC. Now you guys see, angles, and this was the common side. Using angle side, you can easily say both of the triangles are congruent, and you can easily say that AB is equal to AC. That was the proof. This is how you're going to do this. This can be your homework. You can prove this theorem on your own and let me know if you were able to do this or not. This will be the case. You have to try this on your own. I'm going to move forward and start with the sums now. So we have this example 4 with us. It states that in triangle ABC, ABC is a triangle right here. The bisector AD of angle A is perpendicular to side BC. Remember, AD is the bisector of angle A. That means this AD right here is dividing angle A into two equal parts. That means angle BAD is equal to angle CAD. That is the main thing to note here. We have to show that AB is equal to AC. We have to show that AB is equal to AC, and such that ABC is an isosceles triangle. So in short, we have to show that ABC is an isosceles triangle. Now in this proof, you guys have already been given everything that was necessary to prove this. You guys see, this angle is equal to that one. This side is common. This angle is equal to that one, 90 each. So you guys see, angle, side, angle, triangles will be congruent. You can easily say AB is equal to AC, and you can easily say angle ACB equals to angle ABC, CT. So this is the proof. Now let's write given what we have been given. We have been given that angle BAD is equal to angle CAD. We have been given this. What else we have been given? We have been given that angle ADB equals to angle ADC equals to 90 each. Now what is the required to prove? Required to prove is triangle ABC is an isosceles triangle. Now for proof, let's start the solution. So in triangle BAD and triangle CAD, naming is accordingly. You can take any name you want. You can take ABD, you can take ACD, or you can take BAD, you can take CAD, or you can take DAB, DAC. Choice is yours. You can name them accordingly, but you have to take these two triangles. That is the main thing to note here. Now in this case, you guys see, I know angle BAD is equal to angle CAD. Also I know AD is equal to AD, and I know angle ADB equals to angle ADC. This is 90. This is common. That is given. So using angle side angle, triangle BAD is congruent to triangle CAD, and you can say AB is equal to AC, CT, or you can say triangle ABC is an isosceles triangle. Quite easy to prove, right? Now let's move forward and see what do we have in our example. Next one. This is example 5. We have what? E and F are the respectively midpoints of equal sides AB and AC. E and F are the midpoints of the equal side AB and AC. We have to show that BF is equal to CE. Now you guys see, E and F are the midpoints. Now you guys see, whatever the length is this, that is same. This is same, and that is same. Now you guys see, and you have been given that AB is equal to AC. So that means AE is equal to BE is equal to AF is equal to CF, because AB is equal to AC. That is the main thing to note here. We have to show that BF, this BF is equal to this CE. We have to show this. Now for this, we are going to do what? We are going to take these two triangles. Let's firstly take this triangle. And then let's take that one. This one. Okay, we can take these two triangles. Now you guys see, this side is equal to that one, and what else do we have? This angle is common. See, if I just erase this for these two proofs, If I had taken this triangle right here, we had taken this one. So in this, I knew this complete AB. If I had taken this triangle, was equal to this complete AC, right? So if I just draw the angles here, let me just draw it here. It will be like this. This is B, this is F, this is A, and then another one will be like this. This is C, this is E, and that is A. Now you guys see, I can see AB and AC, both are given to me, and I know AE and AF, they are two equal, and I can see angle A and angle A, both are common. So you guys see, side angle side triangles are congruent, and you can easily say BF is equal to CE, right? Easy peasy. Now let's solve this one. So given, what is given? Given is that AB is equal to AC, and I've also been given that E and F are midpoints. So you guys can say, what can you say about this? You can say AE is equal to AF is equal to BE is equal to CF, right? Now what is required to prove? Required to prove is BF is equal to CE. That will be the main thing. Now let's come to the solution. So solution. In triangle BFA and triangle CEA, BFA CEA, I can see AE is equal to AF, I can see BA is equal to CA, I can see angle BAF equals to angle CAE. This is common, this is given, that is also given. So this complete side, that complete side, this is common one, and that is common. So you guys see, using side angle side, using SAS triangles A, B, sorry, we have named it differently. Let's write the correct name here. It was triangle BFA is congruent to triangle CEA, and you can easily say that BF is equal to CE CT. I hope you guys were able to solve this one. This was quite easy. I hope you don't have any doubt on this, right? Now let's move forward and see what do we have in the next part. So we have this one, our example 6. In an isosceles triangle, which is right here, AB is equal to AC, AB is equal to AC, D and E are the points on BC, D and E are the points on BC, such that BE, this BE is equal to BC. We have to show that AD is equal to AE. We have to show this. AD is equal to AE. Now this is quite easy. You guys see, if I just highlight the two triangles right here, let's highlight A, B, E first, and then highlight DAC. Now in both triangles, one thing you can clearly say, see that this side, this AB is equal to AC. One more thing, this BE is equal to CD. What else can you see? Can you see anything else? Don't have anything else. But you do know that triangle ABC is an isosceles triangle, and you just have understood the properties of an isosceles triangle, that angles opposite to equal sides are equal. So can you say this, that angle ABE, this angle will be equal to angle ACD, which is this one. So you guys see, side angle side triangles will be congruent, and you can easily say that AE is equal to AD, right? So let's write the given first. So what we have been given? Given triangle ABC is an isosceles triangle. Therefore, I can say AB is equal to AC. Also, angle ABC equals to angle ACB, because angles opposite to equal sides are equal. Right, that will be the main thing. Now what we have to prove, and also I have been given that BE is equal to CD. We have been given this. Now what we have to prove, required to prove, it is AD is equal to AE. We have to prove this one, and let's come to the proof now. So let me just change the ink. So proof. So we are going to take what? We are going to take two triangles in triangle ABE and triangle ACD. We have to take these two triangles. Now guys, see, I already know AB is equal to AC. I know angle ABE equals to angle ACE, right? That has already been proven. And I know BE is equal to CD. So guys, see, this is given, this is proven, this is given. Side angle side, triangles ABE and triangle ACD both are congruent, and you can say AD is equal to AE, CT. Just invert them and write them again. So that will be the case. I hope you guys have understood the case and you don't have any doubt in this. So that was the solution to your example 6. Now let's move forward and see what do we have. So we are going to start with the exercise 7.2 now. So in this we have what? In an isosceles triangle ABC, AB is equal to AC, bisector of angle B and angle C intersect each other at O. Join A to O and show that OB is equal to OC, AO bisects angle A. Now in this we have an isosceles triangle ABC. Let's say this is an isosceles triangle ABC such that AB is equal to AC, bisectors of angle B and angle C, bisectors of angle B and angle C intersect at point O. This is point O. Join A to O, join this, and you have to do what? You have to show that OB, this equals to that one. AO bisects angle A, and you have to show this, that this angle will be equal to that. Now this is quite easy. You have been given that ABC is an isosceles triangle. So given will be what? Given will be AB is equal to AC. That is the basic thing. You guys know angles opposite to equal sides are equal to. Therefore you can say angle ABC will be equal to angle ACB. And you guys see OB and OC are bisectors of angle B and angle C. Therefore, can you say this? Half of angle ABC, that means it will be angle OBC, or you can say it will be angle OBA, right? Similarly, half of angle ACB, that will be what? That will be angle OCB, or you can say it will be angle OCA, right? So this portion is already equal to that one, this portion is already equal to that one. Now we just have to prove that OB is equal to OC. So for that we are going to do what? We are going to take these two triangles right here, triangle ABO and triangle ACO. So in order to prove our proofs, so let's just start with the solution and proof now. So proof in triangle ABO and triangle ACO, I know AB is equal to AC. Angle bisector. This angle is equal to that one. That will be common and that will be correct. Just do what? Give me a second. Let's just join this. See, if we just approach with that method, what happens here is, see, in order to prove OB is equal to OC, you have to do what? If you take directly these two angles, if you take these two triangles, see, this side is equal to that one, this side is common, and these two angles can be equal because their bases are, their halves will be equal to, because the completes are equal. But that will not be the case, because you will be having this kind of thing. See, angle side angle, which is no property. There is no such property which is side angle. So for this we have to do what? We have to firstly assume this complete figure. We have to prove that these two angles are equal, then we will be coming to the point. So for this, let's approach it differently. For that, see, this will be the case. ABC will be the triangle. See, the bisectors of B and C intersect at O, and let's say this is the case. This is AO, do what? Let it extend and intersect this at B. Now guys, see, in this case you guys already know, if I just do what? If I just assume this one, let's say this side is equal to that one, this complete angle is equal to that one, and what else can we do? See, can we assume this as our height? See, isosceles triangle B and C. Yeah, that will be the case. See, we have to show that OB is equal to OC, right? We have to prove these two. So for this, we have to do what? We have to take these two angles. Now let's start with this. So in triangle, let's start with this ABO and triangle ACO. Let's consider these two. So I know this is equal to that and this is equal to C. AB is equal to AC. I know angle ABO equals to angle ACO, and C, OB is equal to OC. So you guys see, side angle side, triangle ABO will be congruent to triangle ACO, and you can say what? Angle BAO equals to angle CAO. These two will be equal using CPCT. So you have just proven the solution now, and you can say AO bisects angle A as well. So that will be the proof to this question. Now let's see what do we have in the next part. So we have this question with us. In triangle ABC, AD is the perpendicular bisector of BC. AD is the perpendicular bisector of BC. That means this is 90 right here, and it is bisecting the triangle into the base into two equal parts. That means BD is equal to CD. We have to show that ABC is an isosceles triangle in which AB is equal to AC. Now for this, you guys see, this is quite easy. If I assume these two triangles right here, this base is equal to that one. That means BD is equal to CD. This 90 is equal to that 90. This side is common. So you guys see, side angle side, triangles are congruent, and you can say what? You can say AB is equal to AC, CPCT, or you can say this ABD, this angle is equal to that one, and angles opposite to equal sides are always equal, and sides opposite to equal angles are always equal. So this will be the proof to this question. This is quite easy. That can be your homework. So try to do this on your own. This will be your homework, and I'm going to wrap our exercise now, our video right here, right now. So this will be the last sum for today. I will be coming back with the furthermore sums that are left of this exercise, and we'll start with those tomorrow. So if you're having any doubt, you can just ask me down in the comments, or you can just ask me your doubts at our website or on our application. Always remember, you have to practice anytime, and you have to practice anyway, because you have to know how to solve each and every sums. So remember, you have to practice more. And what is the better way to practice with a lot of questions that are already available on our website? We have a lot of question banks there. We have various practice sessions, practice notes there. We have revision notes as well. So just download our application and you can have each and everything available there. Get yourself registered. I'll see you tomorrow with the next session. Till then, practice as much as you can. Bye for now.